Hi there, this is Mamun. Today I come with SPI conversion system. In the previous conversion system, I talked about US ART conversion system, which was a serial conversion system. Let's start today. SPI. SPI means serial peripheral interface. SPI is also a serial conversion system. It's a conversion protocol just like US ART conversion system. To build this SPI conversion system, need two hardware part. One hardware part is called master hardware and another hardware part is called slave hardware. In this conversion system, master can be connected with one or many slaves. In this conversion system, master device will control all the slave devices. Let's make this master slave concept more clear with an example. Imagine you are a master or boss of a company. To complete all the company work, you need to hire slave or worker. In this case, master will command slave and slave will do that. In a word, worker will do whatever master says. This is the main concept of master slave, and this same concept is being used in SPI communication system. As I said, in the SPI communication system, there is a master device. This master device can be your Arduino or any other microcontroller. And slave. Slave can be your sensors like temperature sensor, humidity sensor and other sensors. So in this case, we will use two sensors, for an example, temperature sensor and humidity sensor for slave and Arduino as master. Since Arduino is a master device and temperature sensor and humidity sensor is slave device, so master will be connected with these two slave devices. That means Arduino will be connected with temperature sensor and humidity sensor, and Arduino will command these two sensors what to do and when to do. Till now, I hope we all understood what is master and what is slave. If you have any confusion about master and slave, please comment below. I will try to answer this. Now, the main question comes, how this SPI conversion system works. Let's assume again, for an example, to do a company work, first master will call a slave. Then slave will respond master within a fixed time, and then master will ask him, slave, to do something, or master will want some files from slave, and this way company works will be done. So like this way, same way SPI communication system also works. To do this works, SPI communication use 4-wire. These 4-wire names are SS, that means slave select, SCK, that means serial clock, and MOS, that means master out slave in, and MISO, master in slave out. Here you can see a SPI conversion system circuit diagram. Here is master and here is 3 slaves. So you can see there is 4 wire. This is being used to communicate with each and every slave. So here is 4 wire, here is 4 wire and here is 4 wire. And as I said before, first master will call slave. So through this SS line, that means slave select, master will call the slave. Here is 3 slave. So first through this line, these lines, master will call these slaves, and at the same time master can call only one slave. So master will call any one of these slave, and then using this clock, this clock means master will generate a time, with this time will share by the slave who is being called by master, and with this given time slave will respond this master and and mosi, that means master out slave in. That means through this master will command these slaves what to do, and miso, that means master in slave out. Through this line miso, through this line slave will send data to the master. So now imagine that this master called this slave through this line, and then a clock will generate by this line, and with this clock, or with this time, this slave will respond to this master, and if master want to send some data, then master will use this line mosi, mosi, and if slave want to send some data to the master, then the slave will use, or the master will use miso, this line. Let's go to more details about how SPI conversion system data is being transferred. So there is mainly two things that master want to do with a slave. That is, master want to read some data from slave, or master want to write some data to the slave. So if master want to read data from the slave, then master will use this miso line, miso, this line, and if master want to write data to the slave, then master will use this line, mosi line. So let's go again the previous slide. Here is two graph. This graph is for read, and this graph is for write. So when master want to read some data from slave, so this is the main things is happening under the conversion system. So first master will call a slave. So whenever master will call a slave, this slave select, this line will be goes down, and a clock is being started generating. That means through this line a clock is being started from master, and this clock is being shared by both slave and master, and then master will send some instruction bytes to the slave through this mosi line, and through this instruction bytes slave can understand what master want to do with this slave. So in this instruction byte you can see there is last two byte is 1 and 1. So 1 means read most of the case, and 0 means write most of the case. Actually this depends on the IC or the devices. So for other devices or for your devices, you can find out what is the meaning of 0 or 1 from the data sheet which is being given with your devices. So here is the instruction bits. So whenever the slave got this instruction bit, he will understand what master want to do with him. Then slave want to know the address from where master want to read the data. So then master sent again some data to the slave. This is called address bit. So through this address bit, slave knows from which data master want to read. Then slave will send data using this mosi line. So here slave will send data using this using this miso line. So this is the main way, or this is the concept how data is being read by master. And let's go to a write system. So this is almost same as read. So first master will call a slave. So whenever master will call a slave using this slave select line, this line will goes down. This line will be goes down. Sorry, this line will be goes down, and a clock is being started to generating. So this clock is being shared by both master and slave. So again, master will send some instruction byte. Through this byte, slave will understand that master what he want to do with this slave, and then master will send. So this last bit is 0. So 0 means right. So through this, slave will understand that master will want to write some data to the slave, and then master will send some address where master want to write the data, and then in this address master will write the data. This is the data that is being sent by master, and this data will be saved in this address. And since there is no further communication from slave, so MISO line is not used. So this is the main system or main concept. The data is being transferred in SPI commercial system. So if you have any question about this doubt, you can comment below. I will answer your question. So let's go to the next slide. So there is a good news, that is Arduino Uno or Arduino ID. In the Arduino ID, there is built-in library for SPI commercial system. So the library called SPI.x is in this library. You can easily use SPI commercial system, and using this SPI commercial system, you can add many sensor as you want. So also in Arduino Uno and Arduino Mega, there is some built-in pins. Through this pin, you can use SPI commercial system. For Arduino Uno, 13 pin is called SCK, that means clock pin, and 12 pin is MISO, and 11 pin is MOSI, and 10 is slave select. And you can use 9, 8, 7, 6, 5, 4, 3, 2, all the pins for slave select. So that's for all today. In the next video, I will give an example how this SPI communication system works. We will add a memory card module with this Arduino Uno, and then we will communicate with this memory card module using SPI communication system. So thank you everyone.